Today we're going to talk about right triangles. We've already talked about how to prove two triangles congruent by using SSS, SAS, ASA, AAS, or CPCTC, which is the definition of congruent triangles. Today we're going to talk specifically about right triangles and how we can prove them congruent. So let's look at these here. Also, over here I have a diagram of a right triangle. Remember, the parts of a right triangle are the leg, and the hypotenuse, which is the side opposite the right angle. So what if we know that in two right triangles, their legs are congruent to each other? So what if we know that this leg is congruent to this one, and this leg is congruent to this one? Can we automatically say that the two triangles are congruent? Well, let's check it out. We also know that their right angles are congruent. That's a commonality of all right triangles. And we have a theorem over here, SAS, that tells us if we have a side, an angle, and then a side of two triangles that are congruent, then the triangles have to be congruent. So, we do know that if we have a leg congruent and another leg congruent, then we have two congruent right triangles. This is called the leg-leg theorem. What if we know that the hypotenuses are congruent and that one of the acute angles are congruent? Can we say that those triangles are congruent? If we are told that B and E are right angles, that segment AC and segment FD, the hypotenuses, are congruent, and that angle C and angle D, two of the acute angles, are congruent, can we prove that triangle ABC is congruent to triangle FED? We already have our given information, and if we look up here, we have B and E are right triangles, and what do you know, B and E are right angles, and what do you know about all right angles? That's right, they're congruent. So we can say that angle B is congruent to angle E because all right angles are congruent. And with that information, we already have the markings up here, but we can see that we have angle, angle, side, which is one of our theorems for proving triangles congruent. So angle, angle, side allows us to say that triangle ABC is congruent to triangle FED. And again, the reason for that was angle, angle, side. So we have two ways to prove right triangles are congruent. If you know that two triangles are right triangles, that's important, and you know that their legs, their corresponding legs are congruent, then you know the triangles are congruent. Also, if you know that a hypotenuse and an acute angle are congruent, then you know the triangles are congruent. And the name for this one is Hypotenuse-Angle. Now, both of these have cool acronyms. Leg can be abbreviated LL. Hypotenuse-angle can be abbreviated HA. So what parts do we have left? We've done leg. We've done hypotenuse-angle. What if we have a leg and one of the acute angles? Or what if we have the hypotenuse and one of the legs? Can we prove that the triangles are congruent in those cases? Let's find out. For leg angle, we actually have two cases. If we have two right triangles, and they each have a congruent leg to the other one, you have the possibility of having the angle that touches that leg be congruent, or the angle that does not touch the leg, the angle opposite that leg, could be congruent. So you have to look at each case separately in order to say that we can use them. In case 1, if we give our triangles some names, triangle ABF and triangle CDE, if we start with the knowledge that F and E are right angles, that 2 of the legs are congruent, segment AF and segment DE, and that one pair of acute angles, angle A and angle D, are congruent, then we can make this proof. We know that angle F and angle E are right angles, and you know that all right angles are congruent, so we can say that they are congruent. And if we have that, then we have enough information to prove that the triangles are congruent by angle, side, angle. So we can say that the triangles are congruent by A, S, A. So that's case 1. In order for this to work all the time, case 2 also has to be true. What if we have 2 legs and the opposite angle congruent? Well, we set it up the same way again. We said our given information is that we have 2 right angles, we have 2 congruent legs, and then we have a different pair of angles that are congruent. That's our given information. Our second step again is that angle F and angle E are congruent because all right angles are congruent. And then we have enough information to say that the 2 triangles are congruent, but this time it's by angle, angle, side. So instead of ASA, like in case 1, this time we use angle, angle, side. Since both of these cases are true always, we know that leg angle also works. If you have a leg and one of the acute angles, then you know the right triangles are congruent. So this is the leg angle theorem, and we abbreviate it LA. The final situation we had was hypotenuse-leg. What if we know that the hypotenuse of one triangle, right triangle, is congruent to the hypotenuse of another, and one of their legs is congruent? You can go out and test this as many times as you want, and you'll find that it's always true. However, we can't really prove it, because if we were to prove it, we would be using SSA, which is not one of our theorems or postulates for proving triangles congruent. But since we know that it's true every time we do it, we can use it. We call it a postulate, because a postulate is something that we accept as true without proof. This is the hypotenuse-leg postulate, or HL for short. So we have 3 theorems: leg-leg, hypotenuse-angle, leg-angle, and one postulate, hypotenuse-leg. Let's look at an example of how we can use these theorems and the hypotenuse-leg postulate to prove that triangles are congruent. Suppose we have a diagram like this, and we're told that angle Q and angle S are right angles, and that segment QP and segment RS are congruent. Can we, from that information, prove that triangle PQR is congruent to triangle RSP? Since we're trying to prove that 2 triangles are congruent, we know that we have to use one of these methods. However, we've just learned that if we know that the triangles are right triangles, we have these methods we could use instead. We are told that Q and S are right angles, so that means that we are working with right triangles. So angle Q and angle S are right. And that means that triangle PQR and triangle PRS are right triangles. And the reason we know that is because that's what right triangles are, so it's the definition of right triangles. So we have 2 right triangles. We also know that segment QP is congruent to segment RS. So what piece of the triangle is that? Is it a leg, a hypotenuse, or an angle? That's right, it's a leg. So we could use leg-leg, leg-angle, or hypotenuse-leg? Let's check. If we use leg-leg, we have to prove that these two are congruent. I don't readily see anything that jumps out at me that says that they're congruent. If we use leg-angle, we have to show that either these two angles or these two angles are congruent. And I don't see anything that jumps out at me with that. If we use hypotenuse-leg, we have to prove that this segment, the hypotenuse of triangle QPR, is congruent to the hypotenuse of triangle PRS, and it just so happens that they are the same segment because they share a hypotenuse. And since they're the same segment, we can say that that segment is congruent to itself. So segment PR is congruent to itself. And we know that because we learned way back in chapter 1 or 2 that segments, congruence of segments is reflexive. So now we have hypotenuse-leg, and since we have said that they are right triangles, and we have a leg and a hypotenuse that are congruent, we can say that triangles are congruent. So triangle PQR is congruent to triangle RSP by the hypotenuse-leg postulate. Okay, here's one more example. We need to find the values of x and y so that triangle JKL is congruent to triangle MLK. So we approach this from the perspective of, well, what if they are congruent? If we want them to be congruent, then segment JK has to match segment ML. We know that segment JK is 3x minus 10, and we know that segment ML is 2x minus 15. And if we want the triangles to be congruent, then these have to be congruent also. So we can say that they're equal. And then we go through and we solve this equation. If we subtract 2x from both sides, we get x minus 10 equals negative 15. And then we can add 10 to both sides and get x equals negative 5. To find the value of y, then we would need this angle, angle L, in this one, to match angle K in this one. So we would need 10y minus 8 to equal 8y. So this y is already by itself over here. If we subtract 10y from both sides, we get negative 8 equals negative 2y. Divide by negative 2, and you get y equals 4. So if we want the triangles to be congruent, x has to be negative 5, and y has to be positive 4.